Hello everyone. In today's video, I will be covering the topic elastic. So, elastic constant is of three types: Young's modulus, rigidity of modulus, and bulk modulus. So, first we'll discuss about the Young's modulus. As I have already discussed about the Young's modulus in my previous videos, so you can go and check it out. Here, this Young's modulus is derived from the Hooke's law, and Hooke's law states that stress is directly proportional to the strain within elastic limit. So here stress is directly proportional to the strain. That means, say in this graph you can see that here at this level the stress is 0 as well as the strain is also 0. So when we increase the stress, the strain will also increase. Here again we increase the stress, see here the strain will also increase. But what is written, it should be within the elastic limit. It should be within the elastic limit. So this elastic limit I have already explained in my previous video, so you can go and check it out. Here the Hooke's law states that stress is directly proportional to the strain. Stress is directly proportional to the strain, and to remove this proportionality sign, we have to introduce one constant term, that is capital E. Capital E is nothing but the Young's modulus. So we can rewrite this equation like capital E is equal to sigma by small e, and sigma is nothing but the stress and small e is the strain. So and we already know the formula of stress as well as the strain. Stress is nothing but force per unit cross sectional area, and strain is change in length to the original length. So stress we can write P by A, and strain we can write delta L by L. So the equations became capital E is equal to P into L divided by A into delta L, where P is equal to load or forces, L is the original length of the bar, A is the cross sectional area of the bar, and delta L is the change in length. Now next is rigidity of modulus. Here rigidity of modulus is nothing but the ratio of shear stress to the shear strain, and it is denoted by the term capital G. So here I'll explain you what is shear stress and what is shear strain with the help of this figure. So here I have considered one rectangular bar, so which is placed tightly between two plates. This blue color is the plate. Here this bottom plate is fixed while this upper plate is pulled with a force, and as this top plate is pulled, the rubber will get deformed. This block will get deformed. So this dot line represent the deformed shape, and this black line represent the original shape of the block. So due to this shear force which is applied here, it will deform like this. So the change in the tangential angle in the direction of the force is called shear strain, or we can say that the angular deformation, this angular deformation which is denoted by the term pi, is known as shear strain, and the force which is applied here is the shear stress. Here we can see that the rigidity of modulus is the ratio of shear stress to the shear strain, and mathematically it can be written as capital G is equal to tau by pi. So this shear stress is denoted by the term tau, and this shear strain is by the term pi, and the unit of rigidity of modulus is Newton per mm square, because this tau is the shear stress. So shear stress, the unit of the shear stress is Newton per mm square, and pi is the strain, and strain is unitless. So the unit will be Newton per mm square. Now the last one is bulk modulus, and bulk modulus is nothing but the ratio of direct stress to the volumetric strain. Here this bulk modulus is denoted by the term capital K. So I'll explain you with the help of this figure. Here I have considered one cube which is subjected to 3 mutually perpendicular tensile stresses of equal intensities. Here the equal intensities means the magnitude and nature of stresses are same, and these stresses are also known as direct stresses. And because of these stresses, what happened? The volume of this cube will also get changed. That's why a bulk modulus is defined as the ratio of direct stress to the volumetric strain. So bulk modulus K is equal to direct stress upon volumetric strain, and this direct stress is denoted by the term sigma, and the volumetric strain is denoted by the term E suffix V, and the unit of the bulk modulus is Newton per mm square.